Here we're asked to find the rational zeros of the polynomial, then write the function in factored form. So the first thing we're going to do here is find all the possible rational roots, which is just the factors of the constant over the factors of the leading coefficient, which is just 1, so I don't really need to worry about that. So my possible rational roots here are just going to be the factors of my constant, because all of that's just going to be over 1, which doesn't change the number. So it's going to be positive or negative 1, 2, 3, 4, 6, and 12. So now we're going to use that to find which ones are roots by plugging them in using synthetic substitution. So I'm going to start with 1. Again, I just like to go up from 1 here, and I'm putting my coefficients of my formula here, -1, -17, and 12. So now I multiply 1 times 1, which is 1, 5 plus 1, which is 6, 1 times 6, which is 6. Add these together to get 5. 1 times 5 is 5. Add these together to get -12. 1 times -12. Add these together to get 0. Boom! Because I get 0, that tells me that 1 is a 0, and that x minus 1 is a factor of this giant long equation that we started with. What's left after factoring that out is told by these numbers right here. It tells me that's x to the power of 3, because this is my coefficient, plus 6x squared plus 5x minus 12. Now I'm just going to continue looking using my possible rational roots and plugging it into, now I'm just going to use this kind of shortened thing that I've used or I've created by factoring. So now I'm going to choose -1, and I'm going to use 1, 6, 5, and -12 for my factored form here. 1 times -1 is -1. Add these together to get 5. 5 minus 5 is 0. Multiply to get 0. Okay, this does not get me 0. Not a root. Let's go ahead and try 2. I'm just going down the line here. 1, 6, 5, and -12. Bring down the 1. Multiply. Add. Multiply. Oh gosh, add. This isn't helping. 42. So, okay, this didn't help us either. Let's try -2. So 1, 6, 5, -12. It gets a little bit tedious here, but it's not super difficult because we're just multiplying and adding here. Hopefully it's not too tough. And we do not get 0 here. Sorry, we get 6. So that is not a root as well. Now let's try +3. 1, 6, 5, -12. Bring down the 1. Multiply. Add. Multiply. Add. Oh no, this is not helping either. Okay, a big number not going to help us. Let's try -3. I'm feeling good about this one, people. 1, 6, 5, and -12. Okay, bring down the 1. -3 times 1 is -3. Add to get 3. -3 times 3 is -9. Add to get -4. -3 times -4 is 12. Add together to get 0. Boom! Now I have another root, which is -3, meaning I now have x minus 1 as a factor and x plus 3, because if I were to plug in -3, that would give me that. Sorry, it would give me 0. And now what I'm left over with is x squared plus 3x minus 4. Now at this point, instead of continuing using synthetic substitution, I could continue going, but actually what I should notice here is that I can actually factor this here because it is a quadratic, and I know if I'm looking to multiply to get -4 and add to 3, that would be -4 times 1, or -4. Oh, sorry, no, it would be +4 times -1, because 4 times -1 is -4, and 4 plus -1 is 3. So completely factored, I get x minus 1, x plus 3, times x plus 4, times x minus 1. Now that is completely factored. I should notice I have x minus 1 twice here. So the perfect factored form here would be f of x equals x minus 1 squared times x plus 3 times x plus 4. And my zeros are going to be 1, -3, and negative 4.